Greta is starting to present.
Okay, hello everyone. My name is Greta Bafqari, and this is my bachelor thesis, Geodetic Innovation for Automated Paulownia Tree Mapping. The project integrates UAVs, photogrammetry, AI detection, and survey methods to transform raw imagery into operational survey-grade forestry data. So Paulownia is one of the fastest growing trees, absorbing more CO2 than many other species. I used it as a test site, so we can focus in geodetic mapping, crown with centimeter precision, using UAV's imagery corrected by GNSS, producing reliable data. Traditional approach each time fails. Field surveyors are precise but slow and expensive. Satellites are fast but too coarse to see crowns. The challenge was to design a workflow that combines speed and coverage with survey-grade accuracy and to have more exact data. The method was applied on 38 hectares that expanded to 100 hectares. I'll proceed with National Coordinative System, SPG 6316. This ensures results are correct with cadastral mapping and as a survey-grade outputs rather than simple visual products. We can see now the workflow. The workflow has 6 steps: UAV flights, NDVI classification, AI detection, GNSS georeferencing, and outputs. This transforms UAV's imagery into structured geodetic output that can be used directly for monitoring. So we did flew UAV at, I think now it needs to change the slide. Yanis? Okay, I flew UAV at 80 meters altitude with 80% overlap precision. Ground control points were served using FTK GNSS tied to the national reference frame. This combination anchored the imagery to centimeter accuracy, providing the workflow is truly survey grade. We can see now the data. Control points were placed at corners, edges, and elevation breaks. Balanced placement, minimized block disorientation, improved adjustment. Without proper geodetic design, accuracy collapses at the boundaries. By applying survey principles, the workflow maintained precision across the entire plantation, ensuring that consistency is everywhere exact. The orthophoto that we showed persists with the Silsman orthophoto, a digital surface model. The orthophoto support crown mapping, while the DSMM captures can copy height and structure. Quality checks confirm no gaps and no disorientation. Together, those at this slide, you can see that 38 hectare, the method scaled to 100. Then this provides the workflow is transferable, and once the GNSS and UAVs inputs are calibrated, the process can repeat at larger scale, supporting the regional and national monitoring framework within geodetic standards. Now the NDVI that we show here is vegetation vigor. Red areas mostly represent soil and shadows, while trees crowned recorded high NDVI values. After isolating crowns, 95% of the trees were healthy, then the other were stressed. This helps management focus integration and soil check. Now we can see the YOLO V8. A custom YOLO V8 model was detected at Paulownia crowns automatically. It generates bounding boxes and coordinates for each tree, turning UAV imagery into inventories with minutes. This replaces weeks of manual work with automated analysis, providing surveyors. Now we can see the validation uses 500 GNSS surveyed trees, so we can use them statistically to show the F1 score, while we can see the accuracy come from MC. Together, they confirm both statistical reliability and geodetic precision. Now we can see the workflow mapped those trees across 50 hectares, achieving 92% detection accuracy with F1 score 0.91 combined with centimeter GNSS control. This provides a method is both precise and efficient. Results demonstrate that surveyors can produce operational and remain scientifically valid. Now we can see on the right, on the left is a raw UAV orthophoto, on the right is YOLO V8 detection, illustrates the transformation from imagery to structured data. This contrast demonstrates how surveyors convert pixel into actionable geodetic information Bridging the gap between visual mapping and operational forestry. The model was also tested on drone video. It detected crows frame by frame in near real time. This extends the workflow beyond static orthophotos, opening possibilities for dynamic monitoring. Surveyors could soon analyze plantation life during flights, enable faster, more representative management decisions. Now, all the analyses were performed in Python, integrating QGIS and machine learning frameworks. Using open source tools makes the workflow transparent and affordable. It ensures that advanced methods are not locked behind costly licenses for surveyors, but they are open source, so everyone, even the researchers, can go and see them. The output of the orthophoto, NDVI, and detection were combined in QGIS dashboard. This interface gives managers a single overview of condition by linking survey-grade data to a user-friendly platform. The dashboard transforms geodetic analysis into a practical decision supporting system. This is the final dashboard, or the second dashboard presented that present the performance, such as trees maps, stress, crows, flights, the metrics, simplicity, technical outputs into clear information. This ensures results are not only for specialists, but for everyone. So after this, we're going to develop more exact plan to be the dashboard. In conclusion, the project demonstrates that UAV's GNSS and AI can be combined in a unified scalable workflow. Thank you for the attention.
Thank you. Yes, it was quite technical one. I ask again jury members if someone has some questions. My questions at the beginning was about reference points.
Yes.
Did you use it for how to say? To put the pictures in the right place, or it was to somehow calculate accuracy?
Yes, we used the ground points to georeference the picture and to see if it is accurate. We did measure some control points also to see if any error, for example, that was needed as a reference point, because the national coordinative system of North Macedonia it's not the same everywhere. So for Rakjlë, we needed to use a special reference system.
Mm-hmm. Some other questions? Okay, thank you, Greta. Eugene.
Yeah, just a quick one. Sorry, Yanis, just a quick one for Greta. Thanks.
Yeah.
So after working on this project yourself now, what was the hardest part or the hardest one to overcome as part of your research work?
The hardest part is to do the programming part. So to train the YOLO V8, because my bachelor is in geodesy. I needed to learn more how to train the model and how to test if it is accurate or not.
Okay. Well done. Thanks, Greta.
Thank you.
Thanks, Yanis.
Mm-hmm. Okay. Thank you.